the last two ways in which we're going to prove triangles similar are by side, 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 and side angle side. So these look very similar to when we try to prove when two triangles are congruent. The main difference is when we were trying to prove that triangles are congruent, these sides had to be congruent. But if we look in the definition of side, 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 if the corresponding side lengths of the two triangles are proportional, so they're not congruent but they're proportional, then the triangles are similar. So we've talked about writing a statement of proportionality before, and this here would be that statement of proportionality. In other words, if the statement of proportionality is true, then side, side, side theorem, similarity theorem, will be used to prove that these two triangles are similar. So we need to prove or show that all three sides have the same ratio or proportions. Alright? So I'm going to go ahead and show that with this first example. This first example is asking if either DEF or GHJ is similar to ABC. So we're referring to this triangle here. This is the triangle that we're going to be comparing to. So I'm going to write a statement of proportionality for each of these triangles being compared to the original triangle. Alright, so I'll put the sides for DEF at the top over triangle ABC. Okay. So that would be, I'm going to match up my sides. So we'll match up the red sides together because they should be proportional. 6 to 8, so 6 will go on top, 8 below it. Let's go to the blue one. I have 12 over 16, and then I have 9 over 12. So these are my three proportions, and they should all be equal to each other when I simplify. So let's go ahead and simplify and see what we get. 6 over 8 can be simplified down to 3 over 4. 12 over 16 can be simplified down to 3 over 4. And 9 over 12 can also be simplified down to 3 over 4. So we can see that all three sides have the same proportion, meaning that triangle DEF is similar to triangle ABC. We're going to do the same thing for triangle GHJ. So triangle GHJ at the top, and again we're comparing it to the original shape, which was triangle ABC. Okay. Looking at the red side, I have 8 for triangle GHJ over ABC is also 8. Looking at my blue side, I have 16 for GHJ and 16 for triangle ABC. Finally, for my green side, for triangle GHJ, I have 10 for the green and 12 for the other one. So looking right now, I can already tell that this is not going to be similar, but let's go ahead and simplify. 8 over 8 gets you 1. 16 over 16 gets us 1. But 10 over 12 simplified gets us 5 over 6. You can see that one of the sides is not the same proportion as the other two. So this is not similar. So let's write a statement of similarity for the two triangles that are similar. Triangle ABC is similar to triangle DEF. I am unable to write a statement of similarity for triangle GHJ because they aren't similar, but I know these are similar by side, 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 similarity postulate. Okay. The same goes for side angle side. but instead of having another side, we're going to look for an angle, and we'll do some example problems in class as well.